Hello, everybody. Welcome back. How is the food coma? Is it good? Great. Well, I'm going to talk about something really, really fun and exciting to wake you guys up, and that is monitoring. Yeah? OK, cool. Hands up if you monitor your software. OK, some of you didn't put your hands up. That really scares me. Hopefully, in the next 30, 40 minutes, we'll change your mind and help you understand why it's really, really cool. This isn't just about monitoring. So I've been in the situation, I'm sure you guys can relate, where you go to a conference, you hear about some cool new technology, your mind's exploding with buzzwords, and you get back to your office and back to your desk, and you're like, I want to implement all of the things right now. And you look at the code that you've already got, and the legacy system you're supporting because somebody left the company, and all of the things you're trying to do already, and you're like, well, how do I get from here to this glorious new future where all I'm doing is buzzwords every single day? And this is really kind of the story of how we rebuilt our monitoring systems piece by piece to get to that glorious future, more or less. I want to start out by explaining a little bit of context as to why I care about monitoring so much. So I work for Riot Games out of Los Angeles. We have an office here, too. And I care a lot about games. I'm a gamer. We make a game, conveniently. It's called League of Legends. Have you heard of the game? Some people? Yeah, cool. That's awesome. I love it when people have heard of it because I have a little bit less explaining to do. So it's a popular game. We recently announced we have 100 million players monthly. And as a game designer, 100 million is great, right? Loads of people playing this thing that I love and made. As a backend engineer, I hear 100 million, and I think, oh, that's a lot of things that can go wrong. And they do, right? Nothing's perfect. So our game is about 7 years old, and some key characteristics of it. It's a fairly strategic game. I like to think of it as action, strategy, tactics, all rolled into one. You grab 4 other people, mostly. It's 5v5. You carve out an hour of your time to play. And then you play this kind of big rock, paper, scissors. Who's going to play what? Who are my friends playing? Who are they playing? You get into the game, and you spend an hour making decisions together about what to do. And because it's so complex, people take it really seriously. It's a sport, an e-sport, but it's a sport, right? People get paid to play it. And I kind of wish that sort of thing had been around when I was in college. Just because there's professionals playing it doesn't mean normal people don't take it seriously, too. I take it seriously. And you've spent time trying to get better at the game, get your competitive ranking up, which is why it really, really, really sucks when you lose and it's not your fault. And I don't mean your teammates are bad. I mean this. I hate this screen. Something's gone wrong with the servers, right? I can't get online. I'm in the middle of a game. I'm super hyped up. And something went wrong. And I kind of think of it as my job to stop this screen happening, to help us fix it when it does happen, and stop it from ever happening again. The players don't like this either. They really don't like it. They make memes and YouTube video songs about our servers. And I've been in the glorious position where someone's made YouTube videos about a product I worked on, and they were fantastic, right? They were like fan videos. That's amazing. These are not the kind of videos I want about things that I work on. This is not my legacy. I'm reading too much Hamilton. So what happens behind the scenes when this sort of stuff happens, right? So we have a network operations center. This is NASA, but it's basically the same thing. I'm not allowed to show photos of RNOC, but basically the same thing. And that's a room full of people, 24/7 around the globe. And their job is to detect, respond to incidents, escalate, fix things. What do they need? Information. They can't just sit there and guess. They're not psychic. I wish they were sometimes, but they're not. And so they need information, and that's where monitoring comes in. We need to enable the network operations folks to do their job, and ideally do it with a minimal disruption and minimal escalating to the wrong people at 4 in the morning, which can happen. So the question I like to think my job is answering every day is, how do we reliably monitor stuff at scale? And I'm going to break that down a little bit. It seems like a simple question, right? Well, it's kind of complex in places. I highlight the word reliably because we've been in this wonderful position where if the monitoring systems aren't completely reliable, why do you even have them? What's the point? You can't trust them, then you just resort to spamming the forum refresh and hope no one's complaining. If they're like 80% of the time available and 100% reliable that 80%, I guess they could kind of work. But the real job is to try and get like 100% believability in the monitoring systems. Otherwise, you end up with things like the monitoring team getting paged first, because the folks receiving the alert don't realize that they don't know if it's a real alert or not. It's like, is your system working or is this real? So reliability, number one. Monitoring. That's what this talk is about. What is monitoring? I like to think of it as 3 layers. You've got basic systems monitoring, like CPU, RAM, disk space, network usage, the kind of bread and butter of like the metal, the hardware that you're running on. And if you're starting from scratch, like that's the first stuff you do. The next layer, application monitoring. And this is more fun, right? Is my application even running? Maybe not. If it is running, how's it doing? Is it doing all right? Are there some warning signs? Are things starting to trend the wrong way? Is it behaving badly? Are there error rates? Are there response times? And so you can think of this as like the skeleton outside the app, like response times, error logs, what's going on. Less about the interior logic. Because to me, that is the business intelligence section. And when you talk about a game, you get some really fun questions here, right? Who's playing what champion? Are they winning too much? Are they losing too much? Are people talking in chat about lag too much? Can we detect things like network lag just from what people are saying in-game? Spoiler, we can. It's pretty cool. There's also things like who's logging on from where? Who's buying stuff? Is this normal? Is this abnormal? And as soon as you get into those kinds of questions, you start going back to the network operations. You're like, hey, this is stuff the NOC should probably care about. If nobody's logging in and we're expecting peak traffic and it's not there, that's a live issue. That's just not something you wait for an ECL job and a Tableau report. That's something I care about right now and I'm trying to fix. And so these lines are kind of blurry. And I'll get into a little bit of how we deal with that later. The third part is scale. So games companies have different definitions of scale. And I come from the tech industry where like vastly varying definitions of scale. So I wanted to color this in a little bit. To us, scale is having a bunch of data centers, physical data centers, a bunch of metal in those data centers, a lot of things running on that metal. And then just for monitoring alone, a lot of metrics, 100,000 individual data points per second being sent. Obviously, this isn't where we started, but this is a rough estimate of where we are today. And this is nothing in comparison to like our business intelligence pipeline itself. This is just the standard monitoring pipeline. And again, when I see these kinds of numbers as an engineer, I get really scared, especially when the word, this has to be reliable, is highlighted in the front of my vision, right? These are some pretty annoying numbers to try and keep up. And so this is kind of the story of how do we get there. So life without monitoring is glorious, right? Everything's fine. You can't see the fire. You don't know it's there. It's perfect. So maybe you start out here. You're a startup or something. You're like, oh, I don't need monitoring. It's fine. They're going to tell us if it's broken. And you deal with this for a while. And then you think, OK, what's the most basic stuff I can do? I'm getting a bit concerned about not having anything. So you add network, disk, RAM, CPU, standard stuff. And then maybe you're like, OK, I want a bit more than that, because that doesn't tell me much about what's actually running. Maybe you add stuff like port checks, right? It's like responding on a specific port. That, to me, is like monitoring 101. If you don't have that, then you're not monitoring anything, really. And the problem with stuff like that, in terms of delivering a game as an online experience, is if it's not responding, it's dead. Something's already broken, and it's too late to do much about it, apart from reboot it and hope it works. So you need more complexity than that to try and get ahead of the problem and anticipate incidents before they actually start hurting people's competitive experience. So you Google monitoring, how do I? And you find an off-the-shelf monitoring agent. We did this a few years back. I'm not going to talk about the specific one we used, because it's kind of irrelevant to this story, and I don't want to make it the bad guy. It does monitoring stuff, and it does it pretty well. You end up with something that you install on every single machine, and it runs a bunch of checks for you. It pushes it to a data store. We have one in every data center. It's a monitoring service, so it has things like alerting and dashboards and visualization built in. That's lovely. We realized that in the network operations center, we don't want to open a tab for every data center, especially as we add more and more data centers. So we add something global on top of that. Just a little cache, keeps track of the alerts that are currently going off, gives them a dashboard. Here's everything that's a problem right now. And everybody's happy, right? So happy. And there's unicorns and rainbows, and everything is lovely, and nothing ever goes wrong. Well, not quite. So one of the issues with this system is I need to know what's on the machine to tell it what to check. So we're very tied to things like knowing what is on a specific piece of hardware, what role that hardware has in our ecosystem. And as we move towards the future, that's not really a world we live in anymore. Let's face it. A few other drawbacks. We have a very diverse ecosystem. Our philosophy on stack and software is do what you like, we'll figure it out. So we have like almost every, I hate to say here every programming language, because I know there's going to be some you guys work on that I've never even heard of, but we have a lot of different programming languages in our stack. And as a result, you end up having the monitoring team in the middle, connecting the agent on the box to the thing that's running. Right? You teach it how to talk to Java apps, you teach it how to talk to databases, you teach it how to talk to very specific random stuff that random teams build. And that monitoring team becomes a huge bottleneck. They have to be subject matter experts in basically everything. And they have to keep up. And they get paged when stuff breaks because nobody knows who it really belongs to. They're the only ones that really understand it. You end up with this blurry line between health and business intelligence. And the main thing that happens there is you have lots of arguments. Because say we write a database monitoring check, and part of that check is, are the number of transactions being processed in the database a healthy number? Is it greater than 0, say? That becomes business intelligence, because, hey, I kind of want to know how many transactions we're processing an hour in the store or whatever. Well, can I keep that for like a year? Can I keep that for like 5 years? Well, no, we're going to keep it for a week, because we just care about alerts and debugging and live response. But I want to keep it for a year. So you get these horrible arguments. And it's also like, it's a monitoring system. So some things that it doesn't do. I think if we started today, we use something like Prometheus. Some of these things would not be true, but they're true for the one we chose. Things like, we installed it at the data center level, so you can't get a global view without adding more stuff. Things like predictive alerting, trends, regression, stuff like that, not built in, so we have to add our own. And we end up having to like add them in the connecting glue, which is a little bit awkward for us. Things like, it's a polling-based system. So every n seconds, we get a data point. So we get samples. What's the problem with samples? They hide a lot of things. They hide spikes. They hide anomalies. They tell you like useful things for like memory and disk, perhaps, but they really don't give you everything you need. So we try and solve these problems. Now, having said all this, the thing worked pretty well. Like, we got monitoring that we didn't have before. We are no longer the this is fine dog. We have some information, and the network operations folks are really happy because they suddenly have all this visibility. So this approach wasn't bad, it just wasn't enough. And something happened to kind of evolve this for us. Microservices. I love this. So talking of buzzwords, right? Microservices, or as we kind of call them, just services. Just maybe a little smaller. So we started moving more and more towards this microservice ecosystem. Our engineering organization grew. We added more stacks, more languages, and we end up in a case where one team just can't own monitoring. We don't want monitoring to be their job. We want it to be everybody's job. So this is sneakily a sort of culture talk about how do you change that? How do you get people on board with thinking about something they don't really care about? It's tough. It's very tough. So there's two things that we can do. Kind of a hint on the screen. So we get people to change their minds. We get people to care about monitoring and not just leave it for some people to clean up after them. And we change the data store, data pipeline, to actually a data pipeline rather than a monitoring pipeline. We look at things like the blurred lines. We look at things like how people want to use this data. And we say, well, maybe monitoring isn't special after all. Maybe we can just use the same stuff we use for our big data. Which one do we do first? Well, one is pretty easy, I think. Changing out a technology is not too hard. Changing people's minds, that's impossible, or nearly impossible. So we did that first, just in case it failed, I guess. And we basically took a step back and said, OK, we've got a microservice ecosystem on our hands. How do we make this thing a really healthy, productive microservice environment for developers? How do we get developers all speaking the same language rather than being in a room or shouting at top volume across each other. And there's 3 steps to that. First one is interoperability contracts. So it seems kind of obvious when you look at it. You basically agree for everyone to talk the same way to each other, have a common language, a common way of exposing data. We came up with a spec called Ambassador. I love the name, so I'm going to mention it. And the idea is, if I'm a service, I have to expose these kinds of endpoints. We agreed on HTTP and JSON as our common format for interchange, format for APIs and transferring data. And some of you might think, oh, HTTP and JSON, oh, I've got a favorite thing like protobuf or gRPC or SOAP that's better than that. Why didn't you choose that? This does come around time and time again. But fundamentally, I learned from this a really interesting lesson, which is it doesn't matter what you agree on. It matters way, way, way more that you agree on something. And not everyone's going to be on board with it from day one. But the thing that you create by being on the same page is just so much more powerful than having some rogue person off using protobuf in a corner by themselves. So we have these endpoints, they expose JSON, and the idea is I just put them in my app, and I will be part of this ecosystem. We make this easier, of course. We create frameworks for common languages that have these things out of the box. We integrate with CodaHail metrics libraries and various ports of that library, making it really, really easy for me to get metrics in my app from the moment I start writing it. And things like the status endpoint give us that for free as well. It's effectively a port check, but it gives us a lot more information. All perfect, right? Well, not quite. One thing I learned from this experience is it doesn't just matter what you specify, it matters what you don't, and the stuff around the edges. So you say HTTP, JSON. Some services use HTTPS. I don't know which ones. I always go to the wrong URL, and I realize, oh, it's HTTPS, and I have to go back and change it. So that's kind of annoying, but it is what it is. Another interesting thing is we say you have to expose these endpoints. We don't say where they have to be. So I could have whatever that I like as the preceding URL path. And that leads to some fun moments when you're debugging. You're like, how can I remember where this one is? No, we do say you have to give us a way to expose them in a common way that we can find them. And so here's my little plug for Swagger. I love Swagger. Swagger is a great way of turning basically JSON into a web page, and then you can interact with the API endpoints. And we use this pretty heavily. So we have a guarantee that if you're in our microservice ecosystem, I can go to your Swagger and find you and use you, which is great. Another interesting thing is authentication, authorization. How do you lock down things? Not standardized yet, working on it. But it's one of those things around the edges that we didn't quite specify quickly enough. So I have to try and remember, does this one use an API key? This one uses SSL certificate? This one uses a token? It's kind of fun. All right. So we speak the same language. That's great. But we're also moving towards this world where I'm not just a service on a box. This box is not just a database server. Well, that was a poor example. It probably is. This box does a bunch of things in our backend. How do I find out what's on that box? How do I find out what's running? Kind of bread and butter of microservice ecosystems. You guys are probably familiar with these 2 things, but I want to mention them. Service discovery. So I love it. We use a protocol based on Netflix's Eureka. And the idea is I register a bunch of stuff. As part of my metadata, I specify where is my Ambassador API, so we can find that easily. And we have standardized on how you name yourself and how you identify your location. That makes it super easy to interact with stuff and find it and know what it is. There's one problem, though. So I need to register with service discovery. But I need to find out where it is. But if I don't know where service discovery is, how can I discover service discovery to register with service discovery? We use DNS. We take a format of your location, turn that into a text record query, tells you where they are. Of course, that means that DNS has to work. And you'd be surprised that's not always the case, especially when you're standing up a whole new data center, a whole new shard. So that's fun. So there's always going to be some dependency. It's turtles all the way down. You just get to choose which turtle's at the bottom, I guess. The other thing that I find really, really helpful for metrics especially is dynamic configuration. We have what's effectively a global key value store. That's all it is. And we key based on location, application name, and version, put key values in, get them back out. It is as simple as it sounds. We use Git and Jenkins to push stuff in because that gives us a lot of cool stuff for free, like auditing, like pull requests, reversion, is great. Why do I care about this so much for monitoring? This is more like application stuff now. It allows us to turn things on and off dynamically, turn on and off alerts, change thresholds. And if you're debugging a live issue and you want more metrics, and you've kind of turned them off because you don't want to send a bunch of stuff you never look at, if you have to redeploy your service to add new stuff, that redeploy might well fix the issue itself, because software is software, and sometimes turning off and on again does actually do the trick. So you want to be able to keep things as close to the problem state as possible while giving yourself more debugging information. And dynamic configuration is one way to do that. Of course, if there's a problem with your dynamic configuration code, then you're kind of stuck. But that stuff's really hardened and battle-tested in our ecosystem. So I love this stuff. So we have a bunch of services. We don't care where they are because we have discovery. We know that we can talk to them a specific way. Hopefully you guys have put these two things together a little bit, and the next piece will come somewhat obvious. I have a box. I have some agents on the box. And my agents talk to service discovery and then talk to the metrics endpoint. Now, I could have skipped this slide and made things a little obfuscated and simpler, but we do local discovery on the box. Why? Why don't we just use central service discovery? Two reasons. As a games company, we sometimes have the kind of services that are somewhat ephemeral. For example, a game server that lasts the moment people are in the game and is torn down when people end the game. We don't necessarily want those things to be discoverable in service discovery. We want them to stay fairly isolated onto the box they're on. We also find that this gives us a very natural sharding and scaling. Because if we have a central discovery and a central metrics agent, then we need to figure out how to partition the space of services to scrape for metrics. This means we don't have to solve that problem yet. So that's nice. And then once we get in the box, we just look at the /metrics endpoint. There's also a metrics metadata endpoint that defines alerts. As a service owner, I control that. I can put what I like in there. Looks like this. It's just JSON. We learned that if you say, hey, developer, you have to specify this schema here and register with this registry here and do all these things to get your metrics, they probably just won't. Or they'll come to you and make you do it for them, and we don't want that because that sucks. So it's just JSON. Works pretty well for us. And we change our pipeline. The only thing we changed is the box in red. We keep the rest the same. This is important. This is the changing the engine in flight aspect. Because we don't want to retrain a bunch of people on how to use stuff. We don't want to have a whole lot of new untested code while we're running a live service. And people aren't going to add their ambassador endpoints overnight. So we have to keep running the old stuff while we're also running the new stuff. We overload the same protocol that monitoring service is using. So we insert into the same data store. We kind of impersonate it and look like the same kind of data. And we realize this isn't enough. We need more global services at this point. So we build a full global cache index layer that looks at everything in every data center. And we use Grafana on top of that to give us dashboarding and give us much more powerful tools, while still keeping 90% of our stuff exactly the same as it was, and gradually showing developers, hey, you expose this metrics endpoint, this magic thing will happen. You'll be in this dashboard. What does that look like? I want to show this graph because I love it when people have pictures and not words, and also because it kind of illustrates the point. This uses the same pipeline. It's still running today. We haven't finished changing the engine in flight yet. And you get the ability to see, hey, this thing's spiking. I did this change. It stopped spiking. That's great. So it's not just incident response, but it's also health monitoring on an ongoing basis. Did my stuff change? You get some interesting things like, we started shipping more bytes. I didn't realize that number was low until I noticed that it went up after we did some stuff. And now I realize that's low. So monitoring is this ongoing thing of you don't always know what healthy looks like. And having a lot of data and a lot of dashboards gives us that color and picture. And it helps us give us a tool to communicate between various stakeholders, right? The network operations center, the service developers themselves, even product owners and management, all those people. They love tools like graphs. They tell stories. So we're not perfect yet. In fact, we only changed one thing to a tick, which is sad. So we deal with the biggest problem, ecosystem diversity. We get rid of a bottleneck dependency, And being on the monitoring team is kind of cool now because you're building this platform that's a generic thing that everyone's using. You're not the afterthought janitors trying to get monitoring in at the last minute. But if anything, we make the second point here worse because I'm a developer. I can put whatever I like in my metrics. I'm going to put all the stuff I care about. And that's both health stuff and business intelligence, logic-y stuff. Who's playing what games at what time? And I get really sad because I want to keep that for years, and I can't. A good example of when we ran into this is we moved our entire game server data center from the West Coast to Chicago to make sure that players on the East Coast had better latency. And we used a lot of the metrics that we had around that to capacity plan to see the effect of the move. But if we are thinking about monitoring as something that's fairly ephemeral, it's just data that sends off alerts and then we throw it away. We couldn't have done that. So what happens? We run into scaling issues, my favorite thing, because we're putting more and more things in the system. We have to scale it more. And the monitoring systems start bottoming out. They can't keep up. We had one service developer launch a service without really telling us. And I think the service launched about 500 metrics on every single machine in every single data center all at once. And that, to us, was a significant percentage of our traffic. And our monitoring backend started going crazy. It was like, holy shit, I've got all this new stuff, and I can't keep up. What's going on? And we didn't even know, because he hadn't told us he didn't have to. He just had to expose /metrics, and it all worked. So we didn't have a communication mismatch of, hey, if you're going to do this, you should probably tell us so we can get ready for it and add more capacity. But we didn't have that, and instead we had to scramble to keep up. We also end up writing these tools around the data centers. And again, we can't do things like prediction or trends or alerting. We have to try and get the data out somehow. We run MySQL scripts to get data and run predictions on it. It's pretty messy. And it ends up making application developers have to take on some of that work. They have to start recording rates. They have to start recording spikes themselves and exposing those into the metrics pipeline, which kind of sucks. So that's where we go on to the next step. Change the backend out, use a data backend, not a monitoring specific backend. Everything's going to be lovely, we hope. So we change the pipeline again. We keep the left-hand side the same this time. Well, mostly. We get rid of the data center level storage. Thank goodness, finally. We have a global store, because this is 2016 and we can do that now. And we use a bunch of things that are kind of battle-tested for scale, for much more scale than we need. We use ElasticSearch for our store. We use Kafka to get stuff into it. Our event collector is very dumb. It's really just a buffering measure so that if we have issues between data center and global, we can keep on to data without having to drop it on the floor. And we use HTTP to get stuff in, because that's our agreed-upon protocol. This works pretty well. But of course, our metrics agent does have to learn how to speak HTTP. So we have a little change there. We get a whole bunch of stuff from the switch to a big data backend, like dashboarding, Kibana, Grafana, alerting using Elasticsearch, that we didn't previously have. We do have to retrain people now. Now, we keep Grafana the same, so that looks mostly the same, but Kibana is a whole new kettle of fish. But we didn't have to retrain them on everything at once. We just retrained them on this one thing. So how are we doing? Oh, looking good. Oh, not quite there. This is yellow. It doesn't quite show up. Because we're using a big data-based solution, right, we can do things like determine whether something's a metric or not. We can change retention periods, even access policies. We can provide a lot of tools, because something like ElasticSearch has a lot of tools for interacting with the data and doing things like prediction and trends and stuff. Rates just built in. Statistics are there. We get a global view, but we are still polling, because we didn't change the metrics agent out yet, one piece at a time. And polling isn't perfect, and as everything else gets better, the flaws with what you already have become more and more apparent, right? So we're still polling. What do? We rewrite the metrics agent too. We sneakily can do this at the same time, because we have to change it to HTTP anyway. We start moving more pieces out. Why? Rather than just update it, why do we totally rewrite it? We actually rewrote it in Go because we wanted to make it really, really fast. really resilient. Go concurrency and buffering give us some really, really good tools out of the box for doing this. We can move really fast with the code. We can make it super simple, and it works with our cross-platform diverse ecosystem. We can also share the code effectively. So we end up writing something that's just a tool for pushing batches of metrics to our collector. So why does that need to be an agent? Well, it doesn't, right? It's basically a library. So we go back to our development frameworks, what we originally launched and said, hey, guys, use these. You'll get your API endpoints for free. Now we put the metric stuff in there, too. We say, hey, use these. You can send your metrics however, whenever you like. And we get rid of the problem where you're like snapshotting a metric inside your code, and then the agent comes along a minute later and picks up a really stale piece of data and then sends it, because you're in control. So we move to push-based metrics, and eventually, we don't even need the agent at all. So we kind of make ourselves obsolete. So there's some caveats here. First is that we haven't finished doing this yet, because when you have a system that works, the resistance to changing it can be pretty high, because it works. Why do you care? Like, why should I, as a stakeholder, care about funding a team of engineers to go solve this problem? So you can end up with a wonderful hybrid ecosystem where you have some of the really old version, some of the second old version, and some of the new version all running together. And you have to work really hard to deprecate it. And that's kind of where we're at now, and that's our focus, is just deprecating stuff. We have to make sure that things that don't have those API endpoints built in have a way to talk in the new system. So we build a bunch of sidecars, we call them, to wrap around an existing service and provide those API endpoints and health checks built in. One of the things that was mentioned yesterday is that just because you have metrics doesn't mean you have the right metrics. It's what you don't measure that's normally the thing you want to look at, right? You get paged, it's 4 in the morning, something's broken. Oh, I wish I'd tracked that thing. No, I don't have it. So just because you have metrics doesn't mean you're measuring the right things. And so that's why we ended up with a system that made it really easy for people to add new stuff in. And that has to be really important, right? You have to think about who is your customer, what are they going to need to do, and how do you make life as easy as possible for them. The second caveat is that people have different levels of standards and perfectionism, and people have different levels of caring about stuff like metrics. So if I care a lot about metrics, and I've put loads of stuff in my app, and loads of alerts, and all sorts of things, I'm probably going to get the page, because my software's complaining, even though it's a dependency 3 hops down the line that's actually broken. And you end up with this wonderful microservice fun time where you're trying to figure out what is actually broken just because your service has some error going off. And the best way to deal with that is to look at your architecture, look at your dependencies, and see if you can at least alert with relevant information about what's broken. Not just my service is broken, but my service is broken because it can't talk to this one, or because this thing's not here. But it's definitely something that you have to work really hard as a culture to align around. Let's get ourselves all caring about this stuff, all having the same standard of alerting. And make sure that just because your dependency has alerts doesn't mean that there are people who are on call on vacation this week. So you have to get on the same page about standards of response times and SLAs and all that stuff that as an engineer you kind of try and let someone else handle for you. But you do have to start talking about it. But fundamentally, changing this thing piece by piece helped us focus on what's important to us, helping make sure that developers started changing their minds, caring about monitoring, and making sure that we didn't have some team that was just doing it for them, and making sure the network operations center had the tools to respond to things. And that means that my life as an engineer working on monitoring is a lot more fun than it would have been 2 years ago when we didn't have any of this stuff. And it gives us a chance to, hopefully, the metric I care about most is the number of YouTube videos being created about my product, and I think it's going down. I should get some hard data on that. But fundamentally, you can't change everything overnight, and monitoring is awesome. Those are the 2 things I wanted to say today. Thank you, guys.